All right, welcome back. I hope you took a few minutes to maybe try this example on your own. Maybe you got up and did a few jumping jacks and ate a little snack. I had a Cheeto, so I am back and ready to go. This example says a recent survey asked teenagers whether they would rather meet a famous musician, athlete, actor, inventor, or other person. The circle graph given shows the results. Find the indicated arc measures. So looking at this circular diagram here, pie graph, if we wanted to find the measure, again, and I'm going to use this notation, the measure of arc AC, then we are looking at A to C. And again, remember those angles that they're giving you represent both the central angle and the arc measure. So if this is what we're looking at from A to C, we go the shortest distance possible. Unless told otherwise, so A to C would be 137 degrees if we add that 29 plus the 108. The measure of arc ACD, so this one again gives us a direction. We need to go from A through C and end at D. So we start at A, we add these ones up, we go through C, and then it looks like we're ending at D. So this one is a major arc. And we're going to add that 29 degrees, we're going to add the 108 degrees and the 83 degrees to end up with 220 degrees. And then lastly, the measure of, this isn't lastly, just continuing, ADC. So again, starting at A, this time it has us moving through D, so we've got to go this direction so that we can get to C. Again, we're adding all of those up, so 83 plus 61 plus 79, we should end up with 223 degrees. And then 11, the measure of arc EBD. If we're looking at this, and we want to identify this one, again, we start at E, and it asks us to move first towards B and then all the way to D. So this one actually includes everything except for that 61 degree piece. So we can take 360 and subtract 61, or we could add up all the other ones. Either way, we should end up with 299 degrees. All right, from there, we are going to look at this in a little bit of a different way. So notice the circle graph represents the survey results, right, using degree measures instead of percentages. So when we were doing probability, these looked like percentages. Well, because they are parts of a whole, we could actually convert these into percentages. If we were looking at, for example, 108 degrees is this piece right here. When you create the circle graph, you're using that angle measure to create a correct representation of the section of the whole. Now, 108 degrees in relation to the total 360 degrees, right, is only so much of that. So if I wanted to convert this to a percentage, I would say, well, 108 degrees, right, that's degrees, divided by 360 degrees, the whole circle would give me the percentage there. So if we take 108 and we divide that by 360 degrees, that leaves me with 0.3. So if that is 0.3, then I know that this section right here must be 30% of the students or of the graph. Okay, and we could do the same thing moving all the way around. So if this one is 83, I would take 83 degrees and divide that by 360 degrees. Again, we're using 360 degrees because that's the total. So 83 out of 360 degrees. When you divide that, you end up getting 0.23. I'll write this out. 0.2305, and then 5 goes on forever. So if we were approximating that, we would say about 23% would go here. Maybe I'll write that in red so it looks like the other ones. So 23% of them wanted to meet an athlete. And then if we continue to do that same process, so we divide 61 by 360 degrees, we end up getting 17% here. 79 divided by 360 degrees would give us about 22% here. And then lastly, the 29 divided by 36 degrees gives us about 8% that wanted to meet an inventor. So when you're done with that, because you had to round a couple of them, I just would make sure if you were to add up all of these percentages, they do need to add to 100%. So 30% plus 23 plus 17 plus 22 plus 8 does give us 100%, which represents the whole of the circle. If you ended up with 98%, then you've misrounded a couple of them, because again, it has to represent the whole circle. So we're looking at the total there. All right, so let's answer these questions. It says, what percent of students prefer to meet an athlete? So if we look over here, this 83 degrees represented 23% of the students. And then it says 13, what percent of the students prefer to meet an inventor? And it looked like 8% here if we were looking at this inventor section there. Again, if it asked us how many students, we would need to know how many they actually surveyed, and then we could find 8% of those individuals to do that. So that's the central angle and the arc measure related to a pie graph, which is kind of cool to see in relation to that, and we'll talk more about that as we go. Lastly, let's talk about congruent circles. This is more just understanding the relationship between circles and their arcs. So the first question says, when are two circles congruent? Now, if we have two circles that are next to each other, when are they going to be exactly the same size? Well, that's when their radii or their radius is the same length. So again, and I can't draw two circles of exactly the same size, but here's one and here's another one. Yeah, those look pretty close. Again, if I was given that their measure right here and this guy's measure, his radius, if this one was 5 and this one was 5, then those circles must be the same size, because that radius of length 5 extends all the way around the circle. Now, if one of the radiuses was 7 and another was 5, then those are not the same size, but they are similar. So we know that all circles are similar, so there's two circles there. Grateful for this magic tool that makes it look like a circle. Again, if this one was 5, but this one was 7, those circles are not congruent. They are not exactly the same size. However, they are similar, right? So all circles are similar because they have different radius lengths, but they're all the same based on keeping the same shape. Okay. So when are two arcs congruent then? If we're comparing arcs in different circles, when are they going to be the same? So the first condition is they just have to be in congruent circles. In other words, when you look at the circles that they're in, those radius lengths have to be the same, and then they have to be subtended by the same central angle. So they have to have the same arc measure. Okay. So again, if we were looking up at this example up here, if this one right here has a radius of 5, and I rotate this through an angle of, let's say, 100 degrees. So I'm going to draw another piece right here. I rotate that through, and this is 100 degrees. This arc measure right here has a certain length. If I take this second circle right here, and let's say I rotate him through 180 degrees, right? Now I've created a 180 degree angle. Clearly those arcs are not the same length. They are not congruent. So what they're saying is if you're going to have a circle of the same size, you have to rotate it through the same angle. Both of those conditions have to be met. So if we look down here at a couple of these examples, part A, you'll notice this one has a circle inside of another circle. Remember, we called those concentric circles. And it's asking, are those red arcs the same length, or are they congruent? Now, you can look at that and just say no, right? We can clearly see that one of them is smaller in length. If I were to take a string and lay that on there, one's going to be shorter. You just need to explain why or why not. And in this case, right, they have the same arc measure. Both of these would be a 90-degree arc measure. So we could say they have the same arc measure because they both have that central angle of 90 degrees there. However, these are not from circles of the same size or radius length. I'm sorry, that's messy, but hopefully that makes sense. On this middle one, so if you look at that one, you can ask that same question. Are those ones the same? Well, they also have that same central angle. They've been rotated through the same degree measure. However, notice that this radius is larger than the 4. So when that one rotates through 120 degrees, it's creating a larger arc. So we would say no, and that actually would be for the same reason. So I'm not going to write it out just for the sake of time. They have the same arc measure, but they have different radius lengths, thus they're not the same length. Okay, and then the last one, if you look at this is within the same circle, so they obviously do have the same radius length for sure. And then notice that their central angles are 80 degrees, so they've both been rotated through 80 degrees. So this arc right here, it must be equivalent, or we call it congruent in geometry. So we would say yes, they are from the same circle. That implies that their radius is the same length, and they subtend or are subtended and are, subtended by the same central angle measure. Okay, those are central angles related to their radius lengths and their arc measures. So work through this, again, practicing with that notation, and we will talk more about how to find that exact arc length and find these sector areas within the circle in our future lessons.